So let's do a quick transformer example. Here we have the output voltage of a 75 watt transformer is 12 volts and the input current is 22 amps. We want to know if it's a step up or step down and by what factor is the voltage multiplied. So we have the power is equal to 75 watts. It says that the output voltage is 12 volts, so V secondary is equal to 12 volts, and the input current, I primary, is equal to 22 amps. So for part A, we need to figure out what the voltage primary is so that we can compare it to the voltage secondary. So voltage primary is equal to the power divided by the current in the primary, and that's 75 watts divided by 22 amps, and that gives us our voltages in the primary of 3.409 volts. And since the potential in the secondary is 12 volts and the potential in the primary is 3.5, then Vs is greater than Vp, and in that case this has to be a step-up transformer. For part B, then we have the ratio voltage of the secondary divided by a voltage of the primary is equal to 12 volts divided by 3.409, and that gives me a ratio of about 3.52, and that's going to be the same if I follow the ratio, the number of turns in the secondary over the number of turns in the primary. So that tells me that for every turn in the primary, there's 3.5 turns in the secondary. If I have 2 turns in the primary, that's going to be close, a little over 7. And if I have 3 turns in the primary, that's going to be about 10.5, a little over 10.5. So this ratio can be whatever ratio we want, and we'll still get this ratio of the potentials. So this is an easy transformer problem. There's one on the homework assignment that uses transformer identities, and it's a very common application of transformers, especially in audio equipment. So there's a lot of different uses, but all the equations that are used are the same.